नमस्कार दोस्तों। आज की वीडियो में हम देखेंगे कि जो है किसी भी एरिया में अगर प्रेसिपिटेशन हो गया, सो दैट प्रेसिपिटेशन शुड बी इन ए पर्टिकुलर रीजन। लाइक सपोज सबसे पहले जैसा हम एक्सप्लेन करते हैं कि इसको मेजर करने की, इसको जानने की ज़रूरत क्या है, मीन प्रेसिपिटेशन ओवर एन एरिया जानने की ज़रूरत क्या है। तो जैसा कि हम एक चीज़ हमें हमेशा से पता है, हमने देखा हुआ है। और जैसे क्या होता है कि अगर एक कोई एरिया ये ले लो, लाइक आप किसी डिस्ट्रिक्ट के हैं, सपोज करो मैं दिल्ली से हूँ। सो इन दिल्ली अगर कहीं रेनफॉल होती है, बारिश होती है, तो ज़रूरी नहीं कि दिल्ली के पूरे एरिया में बारिश एक बार हो। ठीक है, हमने कभी देखा होगा कि न्यू दिल्ली में बारिश हो रही है, लाइक हौज खास साइड बारिश हो रही है, लेकिन उधर द्वारका साइड बारिश नहीं हो रही है। नोएडा में बारिश हो रही है, गुड़गांव में नहीं हो रही है। ठीक है। सो ये होता रहता है। लाइक इन 10 किलोमीटर 20 किलोमीटर जो है बाद जो है चीज़ें चेंज हो जाती हैं, जैसा कि आपने देखा होगा कि यहाँ बारिश हो रही है तो वहाँ नहीं हो रही है। सो क्या होता है कि अगर सपोज करो, अब जो ये मॉडलिंग होती है, जो एनालिसिस होती है, वो क्या होती है कि लेट्स सपोज कि हमारे पास कोई बेसिन है। ओके, हमारे पास क्या है, कोई बेसिन है। एक एग्जांपल दे रहा हूँ आपको। उस बेसिन का आउटलेट हमने यहाँ कहीं एज्यूम कर रखा है कि पानी क्या होगा, ये सब क्या है, ट्रिब्यूटरीज हैं। ठीक है, ड्रेन्स हैं ये। जो ड्रेन्स क्या होती हैं, आके कनेक्ट होती हैं उससे बड़े में, उससे बड़े से उससे बड़े में, लास्ट में मेन रिवर में जो है कनेक्ट हो जाती हैं। तो मेन रिवर में यहाँ पे हमको जानना है कितना फ्लो आ रहा है। वो हम किसी मॉडल से, या हम यहाँ पे रोज़ मेजर भी करते हैं, तो वो हमें जानना होता है। तो अगर यहाँ पे बारिश हुई, तो दिस इज़ नॉट श्योर कि यहाँ पे भी बारिश होगी या यहाँ पे भी बारिश होगी। ओके। और और ये एरिया बहुत बड़ा एरिया होगा, हुआ करता है। वो आईएमडी क्या कहता है, आईएमडी ने 0.25 डिग्री इंटू 0.25 डिग्री पे जो है क्या क्या रखे हैं, इंस्टॉल कर रखे हैं। क्या है, नॉट इंस्टॉल कर रखे हैं, दे गिव यू द डेटा और डेटा ऑफ रेनफॉल फॉर ईच अप्रॉक्स 25 किलोमीटर बाई 25 किलोमीटर एरिया का वो देते हैं आपको। ओके, मतलब 25 किलोमीटर बाई 25 किलोमीटर एरिया का देते हैं। तो अगर यहाँ पे कोई रेन गेज है, लाइक इन ए डिस्ट्रिक्ट, इन ए पर्टिकुलर डिस्ट्रिक्ट, कोई डिस्ट्रिक्ट है, उस डिस्ट्रिक्ट में कहीं एक किसी तहसील में किसी ब्लॉक पे लगा हुआ रेन गेज, तो उस ब्लॉक का, उस तहसील का जो रेन गेज लगा हुआ है, वो वहाँ का रेनफॉल को कैप्चर किया। जरूरी नहीं कि वो रेनफॉल तहसील में हुआ हो, जरूरी नहीं डिस्ट्रिक्ट लेवल पे हुआ हो, जब तक दूसरा रेन गेज नहीं मिल जाता। ठीक है। तो यहाँ पे जो बारिश हुई है, जरूरी नहीं हुई बारिश यहाँ पे भी हुई, बारिश यहाँ पे हुई, लेकिन कैसे आप जानोगे यहाँ पे कितनी हुई, यहाँ पे कितनी हुई। तो आपके पास लाइक ये पूरा एरिया है, इस एरिया में यहाँ पे बारिश हुई, यहाँ पे बारिश हुई, उसको आपने मेजर कर लिया, लेकिन यहाँ पे आप तो मेजर नहीं किया, यहाँ हुई कि नहीं हुई कैसे पता। तो एक एवरेज करने का तरीका, लाइक मीन, द टर्म इज मीन प्रेसिपिटेशन ओवर एन एरिया। सो हमारे पास कोई एरिया है, सपोज दैट इज कैचमेंट एरिया। So in that catchment area, if I have number of rain gauges in the catchment area, okay, or grids in the catchment area, on that grid on or that station, I have the rainfall data. But if someone say ki how much precipitation takes place in this basin, in this area, in whole area, then you have to give answer in average terms. Okay, you can't explain those person like at this station this much of rainfall takes place, at this station this much of rainfall takes place, this station this much rainfall takes place. You can't say to that person like this way. You have to report that in a average manner, in a mean manner. Okay, so how we can do this averaging of the rainfall, how can we do? So to do that averaging, we have to think about the methods, if you have random numbers, then for that random numbers you can uh, make arithmetic average, other like this type of average you can use. So the methods we will learn here, and we will understand how we can average the things, average the precipitation or rainfall over area, and how we can report that. Okay. So, introduction is mean average precipitation map. My mean average aerial precipitation is the average rainfall over a catchment or watershed area and is widely used in hydrological analysis. And similarly, why mean average like aerial what is the full form which is written here? Mean aerial precipitation. So, why mean aerial precipitation is important for runoff estimation, for flood forecasting, water resource planning, hydrological modeling, etc., etc. So the methods used to estimate the mean average rainfall to any area, that is a arithmetical method, Thousand polygon method, isohydral method. Okay. This Thousand polygon method I have used in ArcMap or ArcGIS. You can use it in ArcGIS, QGIS. This is the soft. These are the softwares where you can very easily use this Thousand polygon method, which I used. You can do this method as well, but this method I have used, so I am explaining it. I will explain it in a better way. And now let's explain other method as well. So arithmetic method, as you know that I have a value of a station. This value, this value, this value, this value, this value. I have take addition of all the values and then divide by number of values. That is the that is the arithmetic method. Average rainfall is equal to sum of station rainfall number of stations. Suitable when gauges are uniformly distributed. You can use this when your gauges are very uniformly distributed. Very uniform. Where gauges are uniformly distributed. If gauges are uniformly distributed, then we can use this method to do the averaging purpose. And if gases are not distributed properly, and like this is your basin or area, and some gas is here out of the syllabus or out of the boundary, then how we have to do this averaging, that is Thousand polygon method. In this Thousand polygon method, there is way in which we have to do like this weighted area system, weighted average area system we have to select or we have to calculate. So how it works, I am explaining it in a very brief manner. If you want to calculate it in GIS, then it is very easy, but the theory you have to understand behind this. So how it works, like suppose this is an area and we have one rain gauge here, one is here, one is here, one is here, and one is here. How it works, the equation is here, you can see this. The equation is like P1 A1 upon P1 A1 plus P2 A2. Similarly, P1 A1 plus P2 A2 plus dot upon total area. So what is this A1 A2? P1 you can understand. P1 P2 is rainfall of this point, P1 P2 P3 P4. So these are the rainfall at a particular station. But what is A1 A2? How we can you can calculate this A1 A2? And A is nothing. A is the total area of the basin. So how you can calculate the A1 A2 and all? So then this method this is P1. So for that one area, it accomplish or it calculate an area for this P1, like this much area can contribute to this P1 or can responsible for this P1. This area is responsible for P2. This is for P3 and P4 similarly. So how it calculate, what are the method it used to calculate this P1, P2 and P4 and all. Okay, so these are the locations. So first you have to create a line like this. Okay, like we have to connect this in a triangle, and after that it works like we have to mark or we have to extend, like we have to cut this line in a perpendicular manner. Similarly. So you have to do all these things. We have to mark it, we have to match it, and we have to do like this. Then one polygon will be created for a particular particular rainfall gauge, rain gauge. So that area, like that area for that particular that particular rain gauge. Okay, so that area will be A1 for P1, A2 for P2, A3 for P3, and A4 for P4. So we have to give that area to this P1, P2, P3 like this, and after that the whole area you have to divide by the whole area. So by this way it calculate the uh, weighted area and individual rain gauge area. And after that the most suitable and there are three methods, so the last method will be most suitable over arithmetic. That Thissen polygon is better, and this isohedral method is more better than Thissen polygon. So now Thissen polygon, as I explained in previous videos, Thissen polygon, isohedral. What is isohedral? Isohedral is nothing. Isohedral is just a line like contour line. This is just like contour line, a line which joins the same depth of rainfall. Same depth of rainfall. Like at this location, if we go and if you ask the person or anyone how much, what depth the rainfall takes place at this point, and this point, the rainfall should be same throughout this line. Okay, throughout this line. And suppose how it works. So for explaining this, I am going to tell you, from a particular station, suppose particular station, station to a particular point, uh, from this station here, this is line called 12 rainfall takes place in this, to this line. Here suppose this is the area, and here from 12 to 10, this line joins 10 mm. 10, this line join 8 mm, so 10 to 8. Okay, this line joins 6 mm, 8 to 6. Okay, so the area between this area, you can calculate by planimeter, or in question they will give you the area, this area. Okay, so the area is very important. Area is A1, A2, A3, A4. A1, A2, A3, A4. So what is the average of this? 0 to 12 is 11, 12, 11, 9, 7. You have to multiply this to this A1, this to this A2, this to this A3, this to this A4, and divide by total area. What you will get? You will get the uh, average value of rainfall for for that particular area. Okay, for that particular area. Okay, now next slide is, let's see the next slide. Wait a minute, just cleaning it. Okay, next slide is comparison of methods. Arithmetic method is simple. It is moderate accuracy. It is high accuracy but time consuming because area measurement is very risky. And okay, now application is water management, reservoir option, flood studies, climate impact assessment. So all this the measurement or mean calculation is very important, by which we can understand how much area, how much rainfall takes place to a particular area. So that's it for today video, and next video we will learn about some other topic. Thank you.